Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're looking at problem 41, which comes back from 7.1, lesson 7.1, and they want to know which of the following best describes the data in the table of values below. So we have our x's, but the x's have a usually common pattern of just going up by ones. They really want to know what is the pattern of the y values. Because this problem is pretty straightforward, I'm actually going to extend it a little bit and show you what the other answers might look like, but we can do the right answer first. The right answer, if you look at these, involves identifying the pattern of the y values. And so hopefully you can look at it and say, but they went from 3 to 9, 9 to 27, 27 to 81. And clearly they're not adding the same amount every time because that's 6, and this one is 18. And then this one is, I don't know, 54, right? They're not adding the same amount each time. So that one is probably out, okay? So then we want to look at our multiplication, and you'll probably see that you multiply by 3 every time. And if you're multiplying by the same number every time, that is our growth rate or a common ratio, and a common ratio or a growth rate always means exponential. Multiplication, exponential, easy. All right, now I wanted to remind you of what the others would look like, and so I'll try to come up with these on the fly, and we'll see how I do here. 1, 2, 3, 4. Let's go ahead and I'll start at 9 for this one, and imagine I went 9, and then say linear with a rate of change of 6. So let's do 9, 15, 21, 27. Well, if you look at this pattern, I always start with addition and subtraction. It looks to me like we're going up by 6, then by 6, then by 6. You're going up by a constant 6 every time. This one must be linear, and it would be linear with a rate of change of 6. And what would quadratic look like? With a second difference of 12. I may struggle with this, but I'll do my best. 1, 2, 3, 4. You can really pick any number to start with. I started with 9 there. I'll start with 9 again. And let's go up by some amount. And it doesn't matter how much. Let's say I just go up by 2 at first. So this would give me 11. Okay. Then I'm going to go up by 14, and that is going to give me 25. And then I'm going to go up by 26, and that is going to give me 51. Now the reason I'm getting, or the way I'm getting those numbers is to realize we went up by 2, and then this one goes up by 14, and this one went up by 26. There's nothing common there. And you might say, oh, it's multiplication. But multiplying 9 by a number to get to 11 will not be the same number you do 11 by to get to 25. I promise. So instead, we look at the second difference. The second difference down here is constant. It changes by 12. 2 to 14 changed by 12. 14 to 26 changed by 12. This is a common second difference. And a common second difference is always indicative or tells you that our equation is x squared. In fact, it'll end up, I think, being 12x squared. But x squared. Not x to the 12th power, x squared. That is our common second difference. So if you're thinking about what this will look like on your actual final, I don't know off the top of my head, honestly, but I bet because this one was exponential, they'll probably ask you about a quadratic. And our quadratic is the one with the common second difference, so just make sure you're ready for that. Thank you again for tuning in. Hopefully you found this helpful, and I'm excited to keep helping you succeed on your final exam.